about Mr. Mahesh. Mr. Mahesh Gaikwad has completed his master's in computer applications at Vishweshwaraya Institute of Technology. He is having 5 years of experience in the field of cybersecurity. He started his professional career in Security Operations Center, in which the primary objective would be preventing and identifying cyber threats in several organizations. Currently associated with the GCSRT as a technical consultant, he consults organizations for implementation of security devices and technologies to secure them from cyber attacks. He has a certification of computer hacking and forensic investigator. Mr. Mahesh, over to you. And today he will be presenting on cryptography and steganography. So we are waiting for your talk, sir.
Okay, thank you for handing over. Let me start.
You can present your slides.
Yeah, I'm looking at it. Okay, is my screen visible?
Yes.
Yeah, it's visible. I think you have to slideshow. You have to make it. Yeah.
Yeah, I was about to make it. I think there is a delay. Let me check. I said hi now.
Hi.
Okay, oh, fine. There's no delay. Let me connect my charger. I'm setting up. Okay. Okay. So today is one of the interesting and very essential topic. What every individual has to know regarding this, since this technology, what I am going to present today, is being used in all everyday activities as well. If you are what to say, if you are curious of what that is, then we shall proceed. So we are going to talk about cryptography and steganography. So both these concepts are different, but the underlying concept of how a data is manipulated is same. So here today we are going to look at the topics of what is cryptography, why we use that, and different types, and so on. And what is steganography? What was the history of steganography? Whether we had recently introduced it, or there was any logic behind that before what modern steganography was introduced, and various types of steganography, and one of the techniques called least significant bit, which we are going to see how steganography is done, and we will know what is steganography when we come to that point. So exactly what is cryptography? Cryptography was derived from Greek word actually. So crypt means hiding the data in the writing format. In the sense, what it is suppose you have any data, you want that data to be only understood by you and an intended recipient. So you want to send the data to a receiver or an user, then you have to encrypt and send it to the other user, so that only he can get to know what the data is actually. If suppose someone in the middle grabs that data and tries to understand what that is, then he won't be able to understand that. So in order, if you are finding certain difficulties in what words I am using, so let us come to an understanding of what actually the terms which we want to know in order to understand the rest of the topics. So encryption means, suppose you have any data which you can able to read, and that to encrypt in the sense convert that intelligent data to an intelligent inability to read. So whenever a data is converted into an unintelligible manner, so then it is called cryptography. It is encryption. That technology, which is system which uses that, is cryptography. So let's understand based on this scenario. People tend to understand more based on scenario than what is presented as theory or words. So here, this particular user Andy is sending a message, "Hey Sam, how are you?" So so when he wants to send that information to other user, the other user Sam needs to get exactly the same message what Andy has sent. In this case, we could see that there is a change in the data which was sent, because a person named use, who is an attacker, he tried to get into the data and modify the data and send it. So the, now what would be the loss over here? So there is a miscommunication and there is a mistrust between them now. So the reason for this is, the reason for cryptography invention is this reason. So the data what we want to send should be the same at the end of the node. That is the reason why cryptography is needed. A few of the points which we mainly focus on why cryptography is needed is authentication. When you are signing into a Facebook or Google account, you are entering username and password. That username and password will be authenticated onto the server, and then that server is going to provide you service by providing Google apps and Facebook page. That authentication, which is happening is that the username and password what you had sent will be checked against the database and it is going to produce. Encryption should be done to the data which you are sending so that anyone in between should not be able to modify it. That is the reason why for the reason of authentication it is being used. So confidentiality, the data what you are actually holding should be confidential. It should be only secret. It is, if it is secret, it should be only be accessible to you and not to any other person. That is confidentiality. That is the reason why cryptography is needed. So integrity, as in this scenario, "Hey Sam, how are you?" and there is a change in message. How can this person Sam know that whether the message sent by Andy is same when compared with the received message? To check that, cryptography technology is used, called as hashing. So we will come to that as well. Non-repudiation. This concept means, suppose a user has sent you a message, and if that is not like intended for you, or if that was a particular, if it was a bad message, then when you provide, like when you go into when you go into the law for getting the, you want to accuse that person of sending a bad message, then if that particular person who had sent you the message says that he has not sent that, then it will be an issue for you. In order for that not to happen, non-repudiation, that is called non-repudiation. In order to not happen, the if that particular user doesn't says that I have not sent that message, it was not me, in that case, cryptography will make sure that whatever the message was sent was the same delivered to the end user as well. Okay, when we come to types of cryptography, based on the method of encryption, based on the keys, it is differentiated. Symmetric key encryption. What exactly is symmetry? Symmetry means same. So same key is used to both encrypt and decrypt. Decrypt in the sense, whatever the data which was converted into unintelligible manner, that is again reconverted to an intelligible manner. So whatever the code was converted into random string or a text will be converted to a readable format. So that is decryption. Another is asymmetric key, where two different keys are utilized. We will get into that point. And hashing is another one of the cryptographic technique of making sure that the message or the data is secure. So here, if you see the block diagram of symmetric encryption of how the work flows, so when the plain text is encrypted using a certain key is actually it could be a password or a string or a series of text or numbers. So this is only known by the sender who is going to encrypt the data. So here plain text is encrypted using a private key. It is also called secret key. Using that, the cipher text is resultant. This cipher text is, as we have known now, that plain text will be converted into a random characters or string based on certain algorithm, and the same key which was used to encrypt the data will be used to decrypt the data. And then the other end of the node, a particular user, he will be able to
ಹಂಗೆ ಇದೆ ಅಲ್ವಾ ಸಿಸ್ಟಮ್? ನೀವು ಫಸ್ಟ್
understand the data. So here we have come across multiple terminologies over here. So are you all well aware of all these terms: ciphertext, secret key, encryption, decryption? Are you all well aware, or do you want me to introduce that, explain what all those terms are?
Yeah, explain.
Oh.
Manish. Okay. Better explain, I think.
So as you know, any data which can be read which can be in the readable format is a plain text, and that is passed through an algorithm or a function which, based on certain method or a technique, codes that data into a random string or a character or a number, so that only using that same algorithm it could be decrypted. So that random text or string is called ciphertext. So this, when you see, in this file there could be a hello Sam, how are you? But here we are not able to see that data. So it is a in unreadable format. So now this data should be retrieved again to a readable format at the end of the node. So what will be done is, the same key which was used to encrypt will be used to decrypt the data, and we are going to get the readable format. That is what these terms are. So if you see here one of the example of symmetric encryption, here it is mentioned as a transposition cipher. This is one of the method of encrypting text. If you are unsure still now of to know what exactly encryption is, now we are going to give a example over here. See here, this data, meet me after party, it is in a series of boxes where it will have a value of 1 to 6. Now this is arranged in the readable format. If you want to encrypt, the key used is 4 to 1635. Here you have to arrange this in 4 to 1 to 635. If you arrange this, then this columns will be shifted in a particular way of how key was used. The key utilized is this one, and the columns are shifted in that particular way. Now if we read that statement, it will not make any sense. And if we give the suppose I am sending a message to another person, I use this key to encrypt the data which was here. I encrypted it in an unreadable manner. Now what I'm going to do is, if I want the other person to know what that particular message is, I'm going to send him the key, or let him know the what key I use to encrypt that. Then he will be able to actually rearrange the column and get the data. As we came to know that in symmetric encryption, we use the same key called private or a secret key for both encryption and decryption. But in the case of asymmetric encryption, asymmetric means not same. Symmetric means same, asymmetric means not same. Here the word symmetric and asymmetric are being used to suggest what type of what based on the key you utilized, it is named, encryption is named such a way. So here what happens is, this is the sender, this is the receiver, right? Now what happened here, receiver resides and here sender resides. The sender wants to send the data using the public key. There will be two keys in this scenario. One is public key and another is secret key. So both these keys will be generated by both sender and receiver. In a particular case, if a server wants to give access to one of its resource to a client, what it does is, the server will give public key of it, so that the sender or the client can use that public key given by the server to encrypt the data which he wants to send to the server, and then send the data to the server or the receiver. The encrypted data, that is ciphertext, is sent. Ciphertext is sent here using the private key or the secret key of the server. It is going to decrypt. So two keys occur. If we are confused, we will be able to understand that in the next slide, however. And how both asymmetric key and symmetric encryption are both used to give one of the well-known service called HTTPS as well. So here, if you see, two different keys were used for encryption of any data. Public key is used. For decryption of data, private key is used. Public key of receiver is sent to the sender, and decryption is done by the on the ciphertext by private key. As you can see here, it is in a gibberish manner, and you won't be able to anyone in between won't be able to understand. Then the data is sent, and the receiver will use the secret or the private key and decrypt it. So one of the example, well-known example is RSA and DSA. These are algorithms which are mostly used in this scenario. Here in the symmetric encryption as well, there is one of the advanced encryption standard. All these algorithms are well known. You might have no knowledge of all these algorithms in day-to-day life, but in every task of what internet or digital consumption you are making, all these technologies will be playing in the background. Okay, so this is one of the awesome concept of how a private key is sent to the receiver or the sender based on the communication attempt. For example, here this is a server and this is a client. Okay, so now what happens is, this client wants to send a particular data to server, in the sense. Now, in order to encrypt the data, this client wants to send its private key as well. This client wants to send private key to the server, so that both these systems can be working on the same encryption methodology and same encryption key. So now, how in the internet, if you try to pass the key over the internet, what if someone in the middle tries to grab the data and then able to see all the data what you are transferring in between? If what will be the, that will be the one of the worst case scenario. So you don't have to, you won't be willing to risk the security by sending the private key just like that over the internet. If it is over voice, someone could eavesdrop through telephone. If it was being shared in a particular mail, then someone could get the mail by performing MITM attack, man in the middle attack. Those will be the scenarios. So that in order to mitigate that, this concept is used. Here it is, first comes a play of asymmetric encryption where two keys are used, right? Now this will have both private key and public key. This server which wants to receive data from client is going to send public key. This public key is used to encrypt the private key of the client. Okay, so this is the private key, this is the public key of the server. So this key will be used, public key will be used to encrypt this private key of the client, and this will be sent to the server. So now what happens, anyone in middle cannot be able to get this key because it is encrypted by server's public key. This can only be opened by private key of the server. So this will be sent here, and the key which was sent will be decrypted by the private key of the server, and then private key of the client will be utilized for further communication. So now what happened is, using both asymmetric means utilizing two keys, using public key, private key was transferred to the server, and then private key of server was utilized to decrypt the private key, and this private key is utilized to transfer or exchange data in between for further transactions. So whatever the transactions which will happen over the next step will be based on the private key provided by the client. So till now this asymmetric key exchange happen. Here whatever the process is happening will be a symmetric encryption methodology. So this technology where actually is used in is HTTPS. So in HTTPS, whenever we browse through any browser, so we are seeing this, right? Connection is secure. So this is based on HTTPS secure version. So in order to get this notation on, like in order for this to turn green and the padlock to be visible, all the process which I had mentioned over here will be happening between the server and the client, and then that padlock will be visible after there is a successful encrypted connection. So actually, where if we can discuss, encryption is used in many of the day-to-day activities, starting from WhatsApp. In WhatsApp, if you perform a new chat to any other person, it is going to show end-to-end encryption, right? So whatever the messages you are sending to the other person is encrypted along the way. But however, end-to-end encryption is there. But however, what happens in the database of the WhatsApp server will have its own database. All the data might be stored in an readable format. That is one thing. End-to-end encryption will be done when it is being in transit. WhatsApp is one such case. when you are visiting websites, all the data which you are requesting and posting are all being encrypted along the way. The data what you have stored in your laptop can be encrypted and kept, so that whenever the laptop or the mobile device get lost, they won't be able to access it. All these techniques can be done in day-to-day activities as well, so that you won't be at loss when you lose this data, and it that those data can be utilized in any way. So that is one thing to be kept in mind, that as much as possible keep the data in an encrypted format in a protected way, so that it won't be misused. There are applications for mobile applications. We have some Windows applications to encrypt the files and keep in a safe manner. Whenever we want, we can utilize the key to get the data. So even in Google Drive, there are many people who save the important documents and files such as Aadhaar card, DL, all those, and resumes as well. All those you are trusting blindly. You are blindly trusting uh, Google or the service provider where you are hosting or uploading those files. So where all you are unsure or you don't have control, there you have to keep the data in an encrypted format, just to make it a double secure. Even encryption techniques can be broken and the data can be grabbed, but that will take a long time, and it is very difficult if uh, algorithms such as with a key length of 1024 and 2048, if those key length are utilized, then it is very difficult. So one of the interesting concept of cryptography is hashing. What exactly is hash? Consider hash as a fingerprint. Fine. Just like a fingerprint of you, no other person will have same fingerprint. Right. Just like that, hash is also a fingerprint for files in system. In the digital world, for every file there is a fingerprint. That fingerprint is called hash. So how is that calculated? Now for example, if for the data Fox, if we hash it, hash is a certain algorithm which is going to perform it is going to result a random based on a fixed length. It is going to provide the output. So these are the hashing algorithm: MD5, SHA-1, SHA-2, 256, and so on. So these are the hashing algorithms. For example, here for the cyber spirit world, this is the MD5 hash. Now if I just see this, I won't be able to get the word cyber spirit. So now what this concept does is, this encryption and decryption was a two-way function. An encrypted data can be decrypted, the decrypted data can be encrypted, but when hashing, an hashed value cannot be traced back, cannot be rehashed to the real word which we tried to hash it, which we tried to encode it. We can say as an encode. The word cyber spirit was encoded as a hash value of this. So this is the fingerprint for the word cyber spirit, and for every algorithm there will be certain methods on how it is going to perform that hashing technique and resulting in a different manner. So now for example, I am sending you a file, for sending you an important file containing a lot of confidential information, including bank statements, account details, all. So what I'm going to do is, I'm going to hash that particular file. That will result in a, for example, take this hash value. So that particular file will result in a hash value of this, and this along with the file, I'm going to send you the hash as well. So when you receive that particular file along with the hash, you are also going to perform hash on this file, and then you are going to compare the hashes you got and I sent to make sure that the same data was sent and nobody manipulated the data in between the transit. Getting the point? Hello?
Yeah, yes. Yeah, continue.
Yeah, anyone gets doubt, please ask me. I will be surely help you with clearing those doubts. So hashing is just like fingerprint for a particular file. Okay, so whatever a file, even if there is a small change in the data, the whole hash will be changed. No two different file will have same hash. Same file will have same hash. Fine. No two different files, two different data will have same hash. That is one thing to keep in mind. This concept we are utilizing to make sure that the data I sent is same at the receiver's end as well. So here, as you can see, the hash for Fox turned out to be this, and the statements when it was changed turned out to be something else, and list goes on. So the same concept which I had mentioned in like when we tried to send bank account details, if it had changed, what would be the worst case scenario? Okay, so that is, this is in the graphical way. Suppose we are going to now utilize both encryption and hashing to make sure that the receiver knows that the received file is same as the sender file, right? So now take this example. Now you will be able to easily understand this concept. This particular person is sending a message called, "Hey Sam, how are you?" Now he is going to hash that message. Okay, hash that message, which will result in this, which will result in an hash value, and he is going to encrypt that, encrypt the message as well, which will be resulting in this. So now what happens when he is sending that, this particular person, attacker, what he does, he grabs the data and then manipulates it and then sends it. Now if we see, the resulting value is different from here, the hash is totally different from here to here. So what happened is, he will be able to confirm that same hash what he got from the sender and the uh, data which was encrypted, both hash doesn't match. In that case, he sees an error. So now he knows that it is truly not a true data what he had sent previously. Any doubts? Please ask me. Yeah. So now we came to know like what is the use of cryptography in simple terms to keep the data secure. There will be different stages of data in any scenarios. Three types of data are actually there. That is data in rest, data in use, and data in motion, right? In all these three stages, that is data in use, data at rest, and data in motion, all this should be in an encrypted format. What is data at rest? Now you have stored certain files and information in a server or in the pen drive. That is called data in rest. So data which is being data in use is the data what you have stored. When you want to process it, so when you are trying to manipulate it, if you are trying to edit that particular file, then it is called data in use. So when the data which you had stored, you corrected that file, and then if you want to send that file to another user, when the data is being in transmission, when the transmission is being sent, then that data category is called data in motion. So all these category of data are to be made sure that it is in encrypted format, just to make sure that no adversary who has a malicious intent will be able to see the data and utilize the information for malicious activities. In Google Drive, you can also hash the values. In the lab session, what we are going to actually see is how a particular data file is sent to other user by performing encryption, and we will also see what is private key, public key, and how actually the process goes on. In that case, we will have a practical hands-on and see actually in the real world how it works. Until and unless one sees how it works, then most of the concepts will be flying over the head, I guess. So next, what is steganography? Steganography is basic underlying is cryptography itself. The main reason for steganography invention was to make sure that only the sender and receiver know that a secret message was sent, right? No one in between should know a secret message is being passed. In order for that to achieve, steganography was introduced. Steganography is like a very interesting concept. So it is a practice of hiding a particular data in another file. We are going to see what that actually means. If we see historical, if you see in the history, there were many cases of where steganography was actually used. This is not something new, but digital steganography is different. Different way of utilizing the steganography. Previously also, when there were no digital steganography techniques, there were other ways. Here you might have remembered, you might remember that you had used ultraviolet pen, which when you have written on a paper you won't be able to see, but when you turn it back and switch on the UV light torch, then only you will be able to see UV pen writings, right? So you remember, right? Has anyone used this? Has anyone used this invisible ink?
No.
Okay, what this does actually is, when you write on a paper, that won't be visible to the naked eye. But when you project ultraviolet rays onto that paper where you have written using that pen, then only you will be able to see. That is one of the steganographic technique, hiding of data, so that any user who gets the particular file, you won't be able to see what data is being hidden and whether there is any data which is hidden. So another history was wax tablet. What this does is actually, this is a particular wood board where certain carvings or text is written on that, and then on that wax is applied and made it dry, so that for a normal person it will seem like there is no data data written on that particular board. So when the wax is scraped off, then the information will be visible. That is one thing. So microdots is one more interesting technique of performing steganography, so hiding the data. in these scenarios, these dots, as you see in this on the screen, of radius or diameter of one, like both being in millimeters, uh, circles and dots with radius 1 millimeter, if they were zoomed using powerful magnifiers, then there were data which were written on that in this small fonts sizes. So this is one of the where in World War II scenarios this technique was utilized, where a normal paper with a dot in between in a full stop position, wherever the full stop was, where these micro dots were placed, and when the receiver got that particular file, he would actually use powerful magnifiers to zoom in and then see what data was actually printed over there. So null cipher is also one of the text-based steganographic technique, where null cipher, for example, the first character of a first letter of a word in a sentence is extracted and then combined together to see what exactly that data is. We will see the example in next slides. So a symbolic representation of data also is considered one of the steganography techniques. So these are all were performed when there were no digital steganography techniques. So this is the history. However, so if you want to see here, now let me give you an visualization of how a secret data is hidden in an image and then sent to the receiver. Fine. So the file which which is mentioned as top secret is the data which needs to be hidden. The JPG file is called cover file. This is an image file. This file is called cover file because it covers the secret file. So what happens is sender is going to perform steganography technique on this and then merge that, and only the JPG will be visible for any person. So he is going to send that to the receiver. When the receiver gets this, he and sender and receiver would have previously communicated that there will be an image sent where it will contain a top secret file. But this particular person who is monitoring in between, seeing all that communications in between, if he gets the file, he will be just in the assumption that this is just a normal JPG file, and he won't be suspicious of that, and he won't make any good thing out of it. But receiver, as they previously had communicated that I will be sending a particular image file, and then it will have a secret file which will be hidden, that he will extract that top secret file and utilize that. So this is one of the short visualization. Let me show it again. They are going to merge it using steganography technique and then send it, and he is going to utilize it. Now in the previous visualization technique, we saw that an image file was used to hide the top secret file. However, not only image file, there can be multiple formats of files can be utilized to hide a secret file or the secret data. That include, as we previously saw, it includes image file. An audio file can also be used to hide information. Video file also. Email, not just while sending email, the very structure of the email, such as header, contains lot of predefined bits and memory available for that can be used to get information as well. We will be able to see in further slides of how we are going to actually hide and perform the technique. So in the text file also we can hide information, even in the packets. This is called network steganography. In network steganography, the fundamental unit of a traffic is a packet. So all traffic which is moving in between, all the traffic you see in a network is actually packets, right? So in that packet also you can hide the data, where a packet contains headers, headers, source destination, source IP, destination IP, where that particular packet should go, what are the properties of the packet, what data is being stored. All this will be in the packet. So there will be certain fields where which it will be optional and mostly unused. Those fields will be utilized to hide the data in the network steganography case. So we will see by example of how text is done, JPG as well. We will have an understanding of audio in the next slide. Video also will have an understanding, but not with the practical. I mean, not with the situation scenario based. Okay, let us see text steganography. There are many methods of performing steganography on text files to hide confidential information. One being a format based method, linguistic method, and many more techniques are there. But here if you see, this is one of the technique of hiding data in a text file. Here we see that the quick brown fox jumps over the lazy dog. This statement is separated by space, as we usually see. This is called white space. White spaces are spaces, tab, enter. These are all white spaces. So now what we are going to do is, we are going to add extra white spaces at the end of the sentence, at the end of the row, and this white space will not be visible to a normal user when he opens a text file, right? So when a text file is opened, only the text will be visible, but white spaces are not visible. It will be visible only if there is a white space in between the characters. If it is at the end, then you won't be able to see. That's white space also takes memory, right? Even that's white space also utilizes memory. That concept is used to input confidential information, like first character of information what he wants to say. For example, hi xyz. If you want to input hi xyz by hiding here, using these white spaces, it could be hidden in the memory level. That is one of the text steganography technique. So here this is one of the linguistic method technique, or null cipher method. So here if you read this statement, you can see here this is the information which was hidden in this particular paragraph. So here how this was particularly hidden is that every first character in a word is taken and then merged to form the secret word. So this was one of the text based steganography. Yeah, you got this right? So everyone understood this. So image steganography. These are the least significant bit insertion is one of the popular steganography technique for both audio, image, and video as well. We are going to see, and there are many other techniques as well. We are going to see one of the technique called LSB insertion. But here image steganography is this is one of the normal image, but this image was embedded, secret data was embedded into that image file, and now this is an output of that particular steganography technique. So if you see, there is actually a data hidden here. So what we are going to see, we are going to take one of the examples in lab session to see how to embed the secret information into an image and get that and then see that. Okay. So audio steganography, how actually information is hidden in audio steganography is, humans are capable of only hearing 20 to 20 kilohertz frequency of sound, frequency range of frequency. So that results in sound we are capable to hear. But there are many other frequency ranges where we can't hear them. So that concept is exploited to hide the information in an audio file. Fine. So how actually it is being done is, you have an audio file, you are going to insert another audio or any information by you giving it a certain frequency below 20 and above 20 kilohertz. That what that results in is, the information and the frequency which was inputted we won't be able to hear. The only the cover audio file, cover audio files audio will be visible, I mean will be able to hear. So here I have added two audio files over here actually. So I can play this and you will be able to hear a music. Okay, this is the first music I am going to play is a normal original sound, and the second audio file which I am going to play is an embedded audio file. Data is actually hidden, and how you will be able to see the difference between the two. There will be a slight change in quality which will result in noise. You should, if you see, you will be able to clearly observe there will be noise. I am going to play the first song. Can you are you able to hear me now? For now, just confirm so that I can play the file.
Yeah, we can hear you.
Okay, I'm going to play this file. It's a good music, so put on your earphones and clearly observe how these particular two files are different, and observe further noise which it produces. I'm playing the song, you should be able to hear. Okay, so now you heard it, right? So I'm going to did everyone hear that music?
No, we didn't hear the audio.
Okay, how about now?
Once again, can you play?
Yeah, I'm playing it. Are anyone else able to hear?
No, sir.
Okay, I think it will take some time to download for you guys and then play it back. This happened previously when I had checked it. So I will play it again multiple times until you guys were able to hear. No?
Yeah,
Not it?
yeah. Now we are hearing.
Okay, now you are able to hear. Then I'm going to play it again just to make sure that
Yeah,
you compare them. Okay, this is the original file. It's a good music actually. Okay, now I'm going to play the audio file which has an embedded secret message, but you won't be able to hear the secret message, but you will be able to clearly differentiate there is a noise in between, uh, which 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 might provide suspicion that there might be some hidden data. So here you can see the noise. Are you able to hear the difference? Hello.
hello.
No,
Yeah,
sir.
were
It's
you
pretty
able?
soft. Cannot make out the difference.
Yeah, could not make out the difference, but
Yeah,
regardless of,
it's soft. It's not that much. Yeah, that is what I'm trying to make a point here. So it's a very slight change, there will be a very slight or no change visible for visible in the sense in the means of hearing. You won't be able to see much of a difference when you have embedded a secret file. That amount of sophistication is implied on the steganography techniques nowadays. So that is the reason why steganography is one of the important concept of how a particular file or an image is or any data is hidden in a cover file. Cover files include audio file, image file, video files as well. In video steganography, what exactly is a video? It is a series of images and along with an audio file, right? If we know how to perform steganography technique on on image and then audio file, then that will be the same with a video file as well. So that is what I'm trying to make a point here. So what video steganography technique uses is the video, it will divide it into images and extract the audio, hide the information we want to hide in the images using the technique which I will going to be explaining in the next slides. And then it might also hide the information in audio file as well if we did select that option. So these are the other steganography techniques. So in this least, LSB technique is mostly common, so we are going to understand it is a very interesting concept, and we are going to see how we are actually hiding the data. So here, if we see the basic steganographic model over here, actually the steganographic system is actually an algorithm which takes input of cover file, secret message, and key. So in order to hide any image, you need three things. That is cover file. It might be an image, audio, video, even packets, as we mentioned, even email. For now, let us take example of image. So it is going to take input of these three parameters. Key is actually the password you are going to enter just to make sure that the other person who gets this, whom you want that image or an audio to send to, knows that password, and using that password only you will be able to extract that. Fine. Now this steganographic encoder will give an output called stego object, which is a merge of cover file and the secret message. That is called stego object. The key which is used to encode and decode is called stego key, and the resulting output of stego encoder is the stego object. And when it is being sent through communication channel and the receiver send, the same stego object which you wanted to send will be decoded in the receiver send, and secret message is revealed. Now we came to know what is encryption. Now here, if we see the secret message over here is directly passed into the steganographic encoder. If someone somehow the key, he got the key by some means, he knows the password for retrieval of how to decode, I mean extract that particular secret file from the cover file. In that case, now since we have come to know about the concept of cryptography, that is encryption, we are going to add multi-layer security for that. Don't get overwhelmed by this diagram. However, this is a very simple self-explanatory diagram. So let me just go make you through this flow, and you will be able to understand. This particular sender is sending a secret file which is not encrypted here. In previous, this secret file would directly be inputted into the steganography encoder. But what we are adding here is a multi-layer security. I am going to encrypt this secret file by using certain encryption algorithm, say for example RSA. and this will result in an encrypted file now. So even if someone gets this file, he should have at least two keys of this. He won't be able to get using at least using one key. He should have both the keys. So here we are going to send the encrypted file to the steganography encoder. Now this encoder is going to merge this cover file, that is JPG, with the secret encrypted file and provide the output. Okay, as you can see here, behind there is an image. Just for your representation, for your visual representation, I have made sure that it is visible, but surely in the real-time scenarios it won't be the case. Fine. So now the Stego object what we got contains a cover file containing a secret encrypted file. Previously it was just Stego cover file with secret message which was not encrypted. Here secret file with encrypted. So it is going to go through the communication channel. This Stego object is at the receiver's end. Oh sorry, I mentioned encoder here. So it should be decoder. Steganography decoder will get the input of this Stego object, and it will extract the encrypted file which was hidden, and this needs to go into the algorithm which was utilized same here. So the same algorithm and the key what was used should be the same, and then it should the resulting output will be a secret file. So we are actually providing multi-layer security for the confidential file to be sent. So what you can do actually is in some cases, for example, you can experiment with yourself, like you can send it to you can send an image to your friend with few like secret information. Also you could also post it on Facebook, get that downloaded, and then nobody will know that it actually has an secret file. All these kinds of experiments you could be doing. I'm like, while you are uploading to the drives where you have no control, this technique can also be performed to keep it secure. Only even if someone from Google got that file, he won't be able to get the confidential information. So now the one of the steganographic technique used to hide information we are going to discuss. This is one more interesting concept. Please focus on this. It is a very interesting, and you will have a more insight on how. Still now we discussed there is we will hide the data into a cover file. Now we are going to see how actually what is the underlying logic behind that. Now this is, consider this as an image. Fine, and this is a Chrome icon. For an image there will be many number of pixels. An image is a mixture of pixels, series of pixels, at least ranging from hundreds to thousands to 10,000s. So that is the number of pixels which will be usually in an image. If we zoom it clearly, we will be able to see each and every pixel of it. So here what you are actually seeing is a pixel. If you want to see a pixel, if no one knows what pixel actually is, take your mobile, go to TV or for the system monitor itself. If you point that camera to your display on the monitor and zoom in, you will be able to see individual boxes, small boxes, just like this. But however here three colors are being shown because it is much more zoomed. In that case you will be able to see small boxes, that is called as pixels. You might have heard that 441 pixels, 300 ppi when you are buying mobiles, right? So all those are, for every inch there will be 300 pixels. That is what they are mentioning. Now what happens is, if we zoom in on one pixel, this is one pixel. For a color to occur, there are only three primary colors: red, green, and blue. Oh, few other primary colors are also there: cyan, magenta, and some other color. If someone knows, you can point it, say it out, but I don't remember it. But using these three colors, all 16 million colors can be produced. That is one of the interesting concepts. So we are not going into that, but we want to see what is a pixel. Just for that, I just said it. So this pixel, red, green, and blue, when we have given certain values for it, it is going to project that light. And this light acts as an image. That is the science behind it. Let's not go deep into that. We have to know just this, that for this red color to appear in a system, this is the value which will be there. The system will identify this value and project red, and it will provide the information. Just like this value for this is green, and I mean this value is blue, right? Now, least significant bit steganography technique utilizes this understanding that since every data is a binary in a system, and even colors are binary, even image at the end is a binary, if we modify pixels such that whatever data we want, we can enter into that pixels information, but it will not be visible to the normal user when it is viewed. This concept is utilized. How? Now, in this 8-bit binary value, the leftmost, that is the most significant bit, is this side, and least significant bit is this. So if you see 1 2 3 4, I mean 1 2 4 8, it will range. This is the position value for the bit position will be this value corresponding to that position. Suppose if we change the binary bit from, there are only two possibilities, 1 and 0. No, there won't be 2 3 4, right, in binary. So if we change the binary bit from 1 to 0 in the most significant bit, there is a lot of difference from previous to resulted value. So suppose modification was done in pixels such a way that most significant bit was changed. Now you can see a significant change in image production. Okay, so this we don't want to happen. We don't want the image to be completely changed, so that anyone who gets the image should not feel suspicious that there's a modification done, there might be an hidden data. We don't want that to happen. So least significant bit is actually used to manipulate the data of what we want to use. If you change this to 0 now, only, like, if you see a minor change has happened on this from previous to resulting. So the change is very negligible in the resulting image. So I have over exaggerated the image color just to let you know the difference, how it looks. But if you see just from the overview, there is no difference in the color. If you closely observe, there is a brightness decrease, right? So from here to here. So that is one of the, for any steganography technique applied, there will be minor changes. It won't be visible to the naked eye. That is what the point I am trying to make. Now suppose we want to hide letter A in a pixel. In a pixel, if we hide the letter A, in few more pixel, we can utilize few more pixel to hide series of text. Suppose I want to hide an image, hide my password in an image file, then I can use this technique to perform seriatically and then hide my password. But for example, we shall take letter here, how to hide, what we are going to do. Now, since a pixel contains 3 values RGB, we will need this many. So here RGB one set, RGB second set, and RGB third set we need. We are going to use another, and that will be jumped to other pixel. For now, we shall take 3 pixel. This is RGB, RGB, RGB value. Okay, imagine that. Now I want to input the binary value of A into the image pixel so that I can extract that least big significant bits values what I have modified, and then combine that and get the actual value. That is what is actually happening. This could have been better if we had shown in a visualization, but I am trying my best to make sure that you understand the concept of what is happening here. We have taken 3 pixels. Now this is the binary value of A. If you know how to convert this text to ASCII value and ASCII value to binary, then this is what it will result in. The value of first bit is inputted here, second next, and third goes on. What values are here are all inputted in the least significant bit of a byte. So in each pixel we have inputted certain information in the least significant bit, and this is what is from before insertion and after insertion. So if we see with an example of a real image, then we won't be able to make confirmation that there is any hidden information. So that is what actually LSB steganography is technique. In the last bit, the first bit of every binary value of information is hidden in the last bit of the byte. So bit is one value and byte is 8 bits is 1 byte. That is what I am mentioning. So which messages are hidden inside, that is what we have been discussing all this time. So fine. So what are the steganographic tools available? So many are open source as well. Many are open source. These are the different tools available to perform steganography. You don't have to individually go into each pixel and modify that. That is the reason why programs are developed, right? So you don't have to do the manual task. It will be done automatically. You just have to select an image for which you want to hide information and write the image, information, and that will be merged, and then it will produce the output. We'll see all this in the lab session of how an image is used to hide the data. Okay, did I complete on time? Okay, that's fine. Okay, this is it. Any doubts you have, you can ask. This is the time for asking questions. Feel free if I have any doubts. Dr. Chennamma,
Yeah.
that's it from my side for
Okay.
this session.
If any questions from participants? Umarani. Umarani, do you have any questions?
No, sir. Okay.
Okay. No questions, I think.
Okay. What is this?
Okay, and then we can end the session.
Okay, this was sent previously. This is not now. Okay, fine. Yeah, we can end the session. All the doubts which will arise in the future when you get the doubt, cryptography different from steganography.
This question.
Okay.
Yeah.
So how cryptography is different from steganography means cryptography is used to convert the information in an encoded format. That you won't be able to understand the message when you get that information. You will know that a secret message is hidden in cryptography. You will surely know if there is a communication between sender and receiver and there is a secret message being passed, and if that is encrypted, you will for sure know that there is a hidden message being sent. But in the case of steganography, from between the sender and receiver, there might be many files which will be being transferred. If suppose in any one file there was a steganography applied, you won't be able to make sure that in out of that what file is actually contains hidden text. That is what general difference you can find in cryptography and steganography. You will be sure in cryptography that there is a secret information, and in normal steganography you will not be able to identify secret information. You will not be able to make sure of it. Any other questions? Good question. It's one of a good question actually.
Okay.
That's it.
Okay. Then we'll meet again at 2:30 for the demo session. So
Fine.
okay.
So what all we discussed till now is theory, because it is a theory class. So you can't expect practical, and if you are still unsure, see how actually it is being performed in our practical session, and then you will get a much better understanding of what actually hiding and extracting all this information, cover file, all this you will be able to know. And what is encryption, how to use public key, private key, everything we will get to know. Fine. Thank you.
Okay then. Okay, thank you, Mahesh. Let us meet again at 2:30 after
Sure.
the lunch.
Sure.
Okay, thank you.